the previous year questions on the physical science CSIR NET. So before going to start, if you are new to my channel, please subscribe my channel for upcoming videos. So let us solve a few problems here. So first question, consider the differential equation dy by dx square dx plus ay is equal to e to the power minus bt with the initial condition y of 0 is equal to 0. Then the Laplace transform y of s of the solution y of t is. So first what we have to do, the given condition we have to note down here. Then the condition is what? Y of 0 is equal to 0. Y of 0 when t is equal to 0. So y as a function of t is equal to 0. Taking the Laplace transform on both the sides. So the given differential equation, we have to take the Laplace transformation on both the sides. So if we take LHS in terms of Laplace, how we can write dy by dt, that is s dot y, capital Y as a function of s minus y. Here what is the condition? T is equal to 0. So y as a function of t for dy by dt. Then ay is there. A dot y of s. So here the RHS side e to the power minus bt. So we can write directly formula using Laplace transformation. So 1 divided by s plus b. Okay. After that, what we have to do here? This y of t as a function of 0 is equal to what? 0. So this term will become 0. Then what is left here? S dot y of s and a dot y of s. So if we take y of s common, s plus a is equal to 1 divided by s plus b. So y, capital Y as a function of s is equal to what? S plus a into s plus b. So option A is correct here. Okay, next question. A light signal travels from a point A to a point B, both with a glass slab that is moving with uniform velocity in the same direction as the light with speed 0.3 c with respect to an external observer. If the refractive index of the glass slab is 1.5, then the observer will measure the speed of the signal as. So what they have given here, first we should note down here velocity of light in glass. V is equal to what? Speed of light, c divided by n, refractive index. So refractive index of glass slab is what? 1.5. So velocity of light in glass is equal to c divided by n, c divided by 1.5. So velocity of glass s prime. So if we take here what they have given, light signal travels from point A to B. That means it is moving from S to S prime, one frame of reference to another. So A to B, both with a glass slab that is moving with uniform velocity with speed 0.3 c. So what is the velocity of the glass slab here? That is S prime with respect to S, that V is equal to what? 0.3 c. Velocity of light in the ground frame means S to S prime frame. In the first frame, if we take ground frame, we call it is moving from S to S prime frame. So what is the velocity of light in ground frame? Here we have to calculate. So we have the standard formula, that is Vx is equal to, along x direction, if we take Vx prime plus V divided by 1 plus Vx prime into V divided by c square. So whatever the conditions they have given, we have to put in this formula. Vx prime is what? C divided by 1.5, that is velocity of light in glass, plus v is what? Velocity of glass itself. Glass is also moving with speed of light, so 0.3 c. Then again in denominator also we have to substitute. So here c c get cancelled, so remaining 0.3 divided by 1.5. If we equate numerator and denominator, finally we will get here the ratio 1.45 and 1.8. If we further evaluate, we will get 0.81 c. So that is what? The velocity of light in the ground frame. So the option B is correct here. So the next question, so this is the question related to classical mechanics. So from each core subject I am taking one problem here. So the next question, let x denote the position operator and p denote the momentum, canonical conjugate momentum operator of a particle. The commutator here, they have given the commutation relation where beta and gamma are constants, is 0 if this commutation relation is 0 if the value of beta and gamma must be, here 4 options they have given. So let us try to find out here. First write down the given commutation relation. Then as we know the rules for commutation relation, we have to follow here. This is 1 divided by 2m. We can take common. Here first term, whatever it is there, we can take a plus b plus b c plus d, like that we can take. So here 1 divided by 2m is constant, and in this first term, in the second term 1 divided by m is constant. Take 1 divided by m, 1 divided by 2m, that will become 1 divided by 2m square common, and write here the commutation relation p square comma p square, first term. Okay, then next go for the second term, beta x square. So before that 1 divided by 2m p square, again you have to equate with gamma x square. So here 1 divided by 2m and gamma you can take common, gamma divided by 2m. So we can write inside the bracket p square comma x square. Okay, then next what you have to do here, next go for the second, take the second term and equate with these two, beta x square into 1 divided by m p square, beta divided by m x square comma p square. Next here beta gamma you can take common and write the inside the bracket x square comma x square. After writing these conditions, here you can see the commutation relation of similar parameters is going to be 0. This first term and this last term, beta, they are going to be 0. We are left with these middle terms, so write down them, and they have given here this commutation relation is equal to 0. So put here equal to 0. Then next what we have to do here, p square comma x square are common. So if we write it like LHS equal to RHS, here it is 0. So if we equate, we will have here only m and m will get cancelled. Gamma divided by 2 is equal to beta. Then gamma is equal to what? 2 beta. So this commutation, given commutation relation is going to be 0 when gamma equal to 2 beta. So the option here, option B is correct. So the next question here, 2 point charges plus 3q and minus q are placed at 0, 0d and 0, 0, 2d respectively above an infinite grounded conducting sheet kept in xy plane. So these 2 point charges are placed at these given conditions above an infinite grounded conducting sheet. So at point 0, 0 z 0 comma nothing but 3 dimension x y z. So 0, 0 comma z, where z is going to be greater than d. The electrostatic potential of this charge configuration would approximately be. So we have to find out the electrostatic potential at a given point 0, 0 comma. This is nothing but this point is what at 0, 0 comma z. So we have to find out the potential here. So what is the equation for potential? And at z they have given. So here 2 point charges we have. 0, 0 comma z means what? 3 we have to write here. So if we take 2d here, that is minus q. So here 3 minus 1 will become. So here at 0, 0 comma z, that is 0, potential at 0, 0 comma 3. What is the general equation here? 1 divided by 4 pi epsilon naught q divided by d. So here we have the charges as they have given here, plus 3q and minus q, and infinite grounded conducting sheet above. So below we will have the opposite kind of charges, minus 3q plus q. Then we can write the potential at all these 4 point charges. Minus q divided by z minus 2d plus 3q divided by z minus d minus 3q divided by z plus d. Polarity is going to change, plus q divided by z plus 2d. After writing the equation, we can take here z common and minus q divided by this first term is going, if we equate, we will have minus 1 minus 2d divided by z plus 3 plus 3d divided by z. So like that you can write the 4 terms here. After equating the terms inside the bracket, we will get here 2d. That is what q divided by 4 pi epsilon naught z square into 2d. That is what potential at a given point 0, 0 comma z, nothing but 0, 0 comma 3. So option B is correct here. The next question, the relation between internal energy, entropy, temperature, pressure, volume and chemical potential and number of particles n of a thermodynamic system is. So this is the relation that U is an exact differential. If your internal energy is an exact differential, then what is the condition among all these 4 options? Let us solve this. So what is the relation between all the thermodynamic parameters here? This standard equation. If entropy and number of particles are going to be constant, what is the equation for pressure here? P is equal to minus dou U by dou V. T is equal to temperature when volume and number of particles are constant. Since derivative of U is differential of internal energy is an exact differential, we have this condition here. Dou by dou S, these with respect to what? Constant volume, dou V by dou U by dou V. So like that RHS side, if we equate, we will have here in terms of pressure and temperature differential equation. So the option A is going to be correct. The full scale voltage of an n-bit digital to analog converter is V. The resolution that can be achieved in it is. So this is quite easy. The formula for finding the resolution in volts, that is given by the first option, that is V voltage by 2 to the power n minus 1. N is what here? Number of bits. So these are the few problems that I have selected from the previous year question paper. I hope this video is helpful for you. Like that you can solve the problems